All right, welcome back to the next couple examples. Okay, to continue absolute value equations, sometimes the equations might not have a solution or they might only have one solution. So an absolute value graph is not guaranteed to have two solutions. And here's an example, a couple examples where there is no solution. So if I focus on isolating the absolute value for number 3 part A, if I subtract 5 from both sides, you notice that it's going to give you -5. And I have the absolute value 6 minus 4x is equal to -5. And if we try to solve that by hand, I would have 6 minus 4x equals -5 and 6 minus 4x equals 5. Well, guys, none of those are going to work because you can't have an absolute value give you a negative. So I wouldn't do that extra work. In this problem here, I'd go straight to the y equals. And I would verify that it actually doesn't, you can't get a solution from that. All right, if you put absolute value 6 minus 4x into y1 and -5 into y2, and look at the graph, press graph, you will notice that you have your absolute value equation up here, 6 minus 4x and the absolute value, and then you have the -5, which is below the x-axis, and they don't intersect. So an absolute value cannot be negative. So there is no solution. Okay, the graph doesn't cross. Don't waste your time with trying to solve that by hand when you're not going to get anything in the first place. No solution. And the same thing for part B. Now part B looks like it equals a positive, but remember that we have a number multiplied on the outside. So I have to divide that -4. And that's going to give you absolute value of 5x minus 6 equals -7. And again, we got a negative. So once more, we're going to have that same problem. If I do 5x minus 6, -7, and I graph it, I'll get my graph. I'll get the absolute value up here. I'll get the -7 down here. And they're not going to intersect. So we're going to just kind of visualize that and say no solution. And call it a day on that. Now, some absolute values only have one solution, okay? So these ones you got to be careful. And graphically, let's talk about y. First things first, look at your absolute values. In these cases, most of these cases, they're already going to be isolated. So we don't got to worry about trying to add, subtract, or divide or anything out of there. Let's look at what this graph visually looks like. So what I want to do is for y1, put the absolute value. If y2, just put that linear equation. So y1 will do math over x plus 6, y2, 3x plus minus 2. And I'm going to go back to a standard window. If you ever want to get back to a standard window, you can actually go into your zoom and just go to 6. So watching it trace, here is the absolute value of x plus 6. Notice it's shifted to the left this time because it's positive, so minus 6. But also notice, that v goes up here in this direction. This goes over here. It's only going to cross, looks like one time here. I'm going to zoom out again. I probably should have just stayed where I was, but if I do a zoom 3 and press enter afterward, get a kind of a bigger picture of what's going on. So you got your V, you got your line. This is going to go on this direction forever, and this is going to go up here forever, but it looks like they're only going to hit that one spot. So if you do second trace 5, 3 enters, I'm looking at 4. Now, the reason that is the case is because this line has a slope to it, right? It's not a flat line, so it's not going to just be equal to one number. It's going to have a slope to it, and therefore that slope is going to cut into it and only be equal to it there. Where are you going to find that? If you want to look for it by hand, is you're still going to do x plus 6 equals 3x minus 2. And you're going to solve that. So I'm going to subtract the x from both sides. You get 6 equals 2x minus 2. Then I'm going to add 2 to both sides. That's 8 equals 2x. Then I'm going to divide 2. And x equals 4. So there is your 4. 10 is just the value of y when you plug that in, but we don't need that. Well, the thing is if you tend to solve this by hand, then you technically have to do it twice, right? You have to do one with a positive, one with a negative. So x plus 6 equals negative 3x minus 2. And that's going to change that to negative 3x and positive 2. I'm going to add 3x to both sides. I'm going to say 4x plus 6 is equal to 2. Subtract 6 from both sides. And you'll say 4x is equal to negative 4. And divide by 4. And you actually technically get a solution. You get x equals negative 1. That's called an extraneous solution. That's not a real solution. So, if you do it by hand and you get your 2 answers, only one of them is going to work. If I go into my original expression and if I plug in 4, then the absolute value of 4 plus 6, and if I do 3 times 4 minus 2, it's 10 on both sides. But if I plug in negative 1, one side's going to give me 5 and one side's going to give me negative 5. So negative 1, that's an extraneous solution. That means it doesn't work. Therefore, 4 is the only answer that you're technically going to have. But guys, that's a long process. You can see clearly from the graph that 4 is going to be the only answer from the point of intersection. So my point is get the intersection. I wouldn't mess with trying to get 2 solutions here because likely one of them is not going to work, okay? So in this case here, pause the video, try part B, see if you can just get the intersection and find that one point of intersection, and then you don't have to worry about trying to solve them by hand. All right, to wrap things up for part B, I want to just focus on finding the points of intersection with these. I'm not going to go through by hand. So do math, first go to y equals math over to num. Do your 12 minus 2x, and y2 we're going to put 4x minus 6. Okay, you can see that I've been zoomed out from before. So I want to look at, obviously it only hits it at one spot. We can get the answer really quickly. We can just do second trace 5 and hit 3 enters. And that would be 3. So the only thing I really have to write is x equals 3. And we know that's true. I mean, this isn't going to lie as long as you put them in correctly. So just to kind of recap, you can just get the intersection. Call that y1, call that y2, get the intersection, and if you want to draw a little graph of it. X equals 3. And if you want to verify that it's right, go back to your original equation and do math over to ABS, 12 minus 2 times 3. Okay, we get 6, so then go over here and put 4 times 3 minus 6. You get 6 on that side too. So that concludes our absolute value equations with no solutions and one solution. Next, on the back side, on the next page, we're going to do absolute value inequalities.